Hello boys and girls, welcome to Mrs. Bandu's Math Movies. This is Course 2, Lesson 4-3 for my 4th period class. This section is solving equations by adding or subtracting, and that's basically what we're going to focus on. We have some vocabulary and key concepts here that we want to use. We had actually talked about these a little bit in the previous sections without truly giving them the label. So, first of all, addition property of equality. If you add the same value to each side of an equation, the two sides remain equal. Okay, so like if you have something balanced on a balance scale or like children on a seesaw, if you're going to change one side, you better change the other or they're not going to remain equal. Something's going to tumble off. If you can keep that visual in mind when we're solving mathematical equations, we want to keep that same idea. We're going to be a little bit more formal in the way we want things written out here because we're, again, working our way into what you're going to be expected to know and do in algebra. Okay, so if you add the same value to each side of the two sides of an equation, the two sides remain equal. I think I've already read that. So if I'm going to do this, let's say I have 20 divided by 2 equals 10. Here is an equation. So, and 3 is just a random number. If I decide to add 3 to each side, 20 divided by 2 plus 3 is going to give me the same value as 10 plus 3. Okay? Actually, let's just do that math there. 20 divided by 2 is 10, plus 3 is 13, and then 10 plus 3 is 13. So you see, that's what it's trying to tell you. Algebraically speaking, if the value of A is equal to the value of B, then I can add any number to either side, and they're going to still remain equal. So if A equals B, then A plus C equals B plus C. I can add the exact same thing to each side and have them remain equal. The subtraction property of equality tells us the same fact about subtraction. If you subtract the same value from each side of an equation, the two sides remain equal, which again is something that we want to happen in math when we're solving things. Okay, so here again I'm starting out with 12 divided by 2 equals 6. Here I have an equation. So if I want to subtract 4 from the left-hand side of the equation, I need to subtract 4 from the right-hand side as well for them to remain equal. So 12 divided by 2 minus 4, and again 4 is just a number that was chosen at random, equals 6 minus 4. So 12 divided by 2 is 6, minus 4 is 2. So we're going to prove this with our numbers here. 6 minus 4 is 2. So we end up again with an equality that remains, or a true statement. Okay, and algebraically speaking, if A is equivalent to B, then A minus C is equal to B minus C. So whatever A and B are, if they represent the same value, I can subtract the same amounts from each side and they're going to remain equal. Okay, so along with these two concepts, we have the definition or idea of inverse operations. And inverse operations are operations that undo each other. That would be addition and subtraction. So they're like partners, they undo each other. And multiplication and division. When you learned your facts, if you'll think about how you learned facts when you were younger, you learned addition and then used that information to help you understand and learn subtraction. You learn multiplication and then use those facts to help you learn and understand division. So addition and subtraction are inverse operations. Multiplication and division are inverse operations because they undo each other. Okay, so now here is the nitty-gritty of what we're going to be doing in this section. I'm also going to tell you, I'm going to show you in class, I don't want to do it on here, A, because I don't want to throw too many things at you at one time, and B, I want you to have some lined paper because your life is going to be a little bit easier if I'm trying to show you some variations on this if we use lined paper. Okay, so first of all, we want to say solve t minus 58 equals 71, and then we want to solve the solution. So really, our first thing we want to do here is look and see what operation is involved. Here we see that it's a subtraction problem. And what I want to do here is, first of all, what's the opposite of subtraction, or the inverse operation? And that would be addition. So that means I'm going to use addition, the addition property of equality most specifically, to solve here. Okay? So I'm going to say t minus 58, so I'm going to add, actually, 58 to each side of the equation. Again, if I'm going to change or adjust one side, I must change or adjust the other side in exactly the same fashion. Okay? If I do minus 58 and plus 58, those zero out, okay, because they are additive inverses. If I think of this as plus negative 58 plus positive 58, negative 58 plus positive 58 is 0. Okay, so this gives me t plus 0. Eventually we won't be writing the 0, but for explanation purposes today we'll write that. Then I actually add 71 plus 58. So 8 and 1 is 9, nothing to carry. 7 and 5 is 12, so I write down a 12 in front of that. So I get t equals 129. This is the additive identity property. The reason it says that here is because any number plus 0 equals itself. So t must be 129. Okay. Now what we want to do here is check the solution into the original equation. So we're going to substitute, and again we practiced this a little bit earlier in this idea of substitution. Alright. So we're going to do 129 minus 58. So 129, I'm going to write it this way so I don't make any mistakes, or hopefully I don't. So 9 minus 8 is 1. I'm going to have to borrow. 12 minus 5 is 7. So I get 71 equals 71. Because when I put my answer of 129 in the problem, my solution checks. So 71 equals 71, that tells me, yeah, the 129 is correct. Okay. I know that's a lot of information coming at you kind of quickly. If you need to stop your video and be sure everything's filled in, you might want to replay this section and try to just follow through with me. Again, of course, we are going to be going over this much more in class as well. So the idea is, though, that you're coming in with an idea of what we're going to be trying to do. So don't be too upset if you don't quite, everything doesn't quite make sense. Being exposed to it will help you. By the next time we see it, you may have questions and begin to understand if you don't already. Okay, solving equations by subtraction. Your friend purchased a DVD and a CD. The DVD cost $6 more than the CD. So I'm pretty sure that's going to be important. I'm going to underline that. The DVD cost $22. How much did the CD cost? Okay. So again, what we're doing here is we're going to write an algebraic equation, and then we're going to use our properties to solve. Okay, so first of all, the cost of the DVD is $6 more than the cost of a CD. So basically, this sentence right here is setting up the whole entire problem for you. Okay, if C is the cost of the DVD, and this is called defining your variable. And I do want you folks to do this, because if you have a word problem, you need to know what you're looking for. And just by writing a little statement like this, okay, it can help you become less confused about what you're doing. I do require it in my algebra classes, by the way, so you're going to want to get in this habit. Okay, so the cost of the DVD is $22, and it is equals $6, more than, plus C, the cost of the CD. Okay, so that basically gives me my equation. 22 equals 6 plus C. Okay, now what my goal here is to get the variable left alone all by itself. So I'm going to subtract 6 from each side because I want C to be all alone. So again, whatever I'm going to do to this side of the equation, I'm going to treat the other side of the equation the same way. 6 minus 6 is 0 plus C. And again, if you like to write the 0 plus C down, you can. You don't absolutely have to. Most of us eventually are going to want to make that jump into just writing in the C. 22 minus 6 is 16. So that tells us that the cost of the CD should be $16. Okay, let's see if this checks. It didn't ask us to, but let's. So if we do 22 is equal to 6 plus 16. See if that checks. 6 plus 16 is, in fact, 22. So that means our answer is checked. Sometimes I will require that you write out a check, sometimes maybe not. You should always know how to do a check. Remember, it's simply substituting back into the equation and finding out whether or not it gives you a true statement. Okay, have the 2 quick checks ready, and any questions you might have thought